First, the purpose of this lab is to compare the observed and the predicted motions of mass oscillating on a spring using fundamental physics principles. And here's the brief preview of the results. The energy principle holds true. The fundamental physics principles used in this analysis includes Newton's second law, which relates force to acceleration, and the principle of energy conservation, indicating that energy within a system remains constant. Kinetic energy represents the energy of motion, while gravitational potential energy is associated with the object's height. Spring potential energy arises from the deformation of the spring as described by the Hooke's law. Alright, so here are the formulas that we are going to use throughout the lab. First is the position update formula, then the velocity update formula, and then the spring force and the change in energy in the system, and the kinetic energy and the potential energy and the spring potential energy. So for this lab I chose option 1, and the corresponding video was analyzed using tracker software to obtain the x and y positions of the oscillating mass. These measurements were then compared with the predictions from the computational model. The system is the mass, spring, and the earth, and surroundings is nothing. So here's the experimental model that I did using tracker. Here are some of the data in the x position and y position, and in the top right you can see the position time graph for the x direction and the y direction. So here are the initial conditions that were made. The mass was changed to 0.402 kilogram. The position was changed to negative 0.12, negative 0.65, 0, which was gotten from tracker, and the velocity is just 0. And delta t was changed to 0.095, which was also gotten from tracker. The spring constant was 6.83, and a L0 relaxed length of spring is 0.123, which was gotten from the video provided. And then we found L, which is ball dot position minus spring dot position, and then L hat, which is L divided by magnitude of L, and then S, which is magnitude of L minus L0. And then we found kinetic energy, gravitational potential energy, spring potential energy, and the total energy was just 0. So here's the code after the initial conditions were made. The force of gravity was changed to have ball dot m times g in the y direction, and the force of spring is just negative ks L hat. F net is adding those two together. Ball dot velocity is just the velocity update formula, and ball dot position is position update formula. L is just ball dot position minus spring dot position. L hat and S is calculated the same as I showed you earlier, and the kinetic energy was calculated using half mv squared, then delta k, which is kinetic energy minus initial kinetic energy, and gravitational potential energy, which was mg delta mgh in the mg ball dot position in the y direction, and then delta gravitational potential energy was just gravitational potential energy minus initial gravitational potential energy, and then spring potential energy is just half ks s squared, and delta spring potential energy was just spring potential energy minus initial spring potential energy, and the total energy is just 0. Here are the results. The top left is comparing the x position and time, and the bottom left is y position and time, and bottom right is just comparing the energy change in energy. So the total change in energy is observed to be 0 because the gravitational potential energy and spring potential energy have opposite signs, and combined with kinetic energy, these energies sum to 0. The x and y position graphs for both the observed and predicted motion models are sufficiently close, indicating a successful computational model, and suggesting that there were no significant errors in the physics involved. Although no significant physics errors were identified, several potential sources of error remain. Human errors such as inaccuracies in measuring the positions on timing during the video during the video analysis could affect the results. Additionally, the model did not account for drag force, which can influence the motion of the mass as it oscillates. So what does this mean? Energy is conserved throughout the experiment, and as previously demonstrated, the total energy remains 0. This indicates that the energy transformation between kinetic gravitational potential and spring potential energy balance out, confirming the principle of energy conservation in the oscillating system. Additional questions. The time taken for 4 oscillations in the x direction was 6.48 seconds, resulting in an oscillation period of 1.62 seconds. In the y direction, the time taken for 4 oscillations was 5.13 seconds, which was leading to an oscillation period of 1.29 seconds. That results in a difference of 0.33 seconds between the two periods, which is significant. Such a discrepancy could introduce errors in the calculations of spring force and potential energy. Thank you. That's all I have for you.